Okay, Duarita. Last time we was working on the properties of line segment and on the properties of angle, and we established some result. We worked on some results that the line segment, the measure of the line segment, they are basically reflexive. For example, the measure of AB is equals to measure of AB. At the same time, the measure angle A is equals to measure angle A. This property of angle and of line segment is called reflexive property. Okay. Then, if measure AB equals to measure CD, this implies measure CD equals to measure AB. This property of line segment is called symmetric property. Okay. And in angles, how we can replace that? If measure angle A equals to measure angle B, that implies measure angle A, measure angle B equals to measure angle A. Okay, these properties are called reflexive, and this one is symmetric. Now, very important property of the line segment and of the angles is basically the transitive property. What it means, if measure AB equals to measure CD and measure CD equals to measure EF, then measure AB, that is equals to measure EF. Okay, that means if this one is equals to this one and this length is equals to this length, then the first one is equals to the last one. Okay, is it clear? And in
Yeah.
terms of angles, we can say that if measure angle A equals to measure angle B and measure angle B equals to measure angle C, this implies measure angle A equals to measure angle C. This property is called the transitive property of angle. Okay.
Mhm.
Okay. Now, by using these properties, we were using the equality sign. Let me just tell you one more thing. The reason was that because when we say measure length AB, that means either it would be 2 centimeters, whatever the measuring units we are taking, it is 2 centimeter, it is 3 centimeter. So this is basically well defined. Okay, this is well defined, or it is obviously a, it is a positive real number. Okay, but when in abstract we have to write that two lines are two line segments are equal, so we will not write that they are equal. We will write that the line segment AB is congruent to the line segment AB. This will turn into the reflexive property. We will use the congruency sign now. Okay. In abstract, we will use the congruency sign, but in if we are if we know or if the lengths are defined, then we will use the equality sign. Okay, and same in the case of um, angle measures, we can write angle A is congruent to angle B or angle A if we haven't any idea what is the exact angle measure is. Got it? Is it clear? Can you hear me?
Yeah.
Yeah, then please respond. Okay, so is it clear, or do you have any question?
No.
Okay, now moving forward, we have a very interesting definition of proof. What is a proof? A proof is a logical argument. What is a proof? A proof is a logical argument that uses deductive reasoning. Can you tell me what is deductive reasoning? We are already done with this. Wow. What is deductive reasoning? There are two types of reasoning. One is inductive reasoning and one is deductive reasoning. In inductive reasoning, you are given with a journal statement, and then by using that journal statement, what you have to do, you have to find out, uh, you have to deduct it to a particular scenario. For example, all uh, all men are mortal, right? This is a journal statement. Now, the induction would be Hamza is mortal. Okay,
Hmm.
am I right?
Right.
Yeah. So this is inductive reasoning. Now, what is the deductive reasoning? With some powers, with by knowing some of the reasons, some uh, local truths, to generalize them to a global truth, to reaching out the global truth. This type of reasoning is called deductive reasoning. For example, um, we can say that. Uh, can you give me an example
About deductive reasoning?
for deductive reasoning?
I'm thinking.
Yeah, just think for Indian.
So like it starts with like something general, and then it applies to like a specific like case, but then
Mhm.
it has a certain conclusion.
Yeah, exactly. For example, if we just see, I'm giving a very easy example. For example, we observe that one is a natural
Bashir.
number, right?
So if
At the
number,
same time, at the same time, it is an
so
integer.
I have one.
Okay, yeah, please.
So like if a number is a divisible by four, then it is even, and then
Yeah,
the
first
fact
we will
of
have
that.
some. First we will have some examples, right? For deductive reasoning, we first have some particular examples, right?
Yeah.
And then we will make a journal statement, or we will make a particular statement.
A, a journal statement.
We will make a journal statement or a particular statement.
Per no journal. You'd make a journal statement.
So in deductive reasoning, you have a journal statement, and from that journal statement, you will make some particular statement. Okay.
Yeah.
And in inductive reasoning, we have some journal statements, and from those journal statements, we will make some object. We will have some statement must be local true. We will make a global truth from that. Okay.
Hmm.
Then what initially I said. Did I said the same thing? Maybe. Uh, let's move forward. Okay, now is it clear? The deductive reasoning is the reasoning in which we are given with a general statement and we are getting a particular statement. And in deductive reasoning, we will be given with some, we will find some particular examples, and from those particular examples, we will try to get a generalized statement. Okay, that is inductive reasoning. Okay, now moving forward, we will use logical argument that use deductive reasoning. Now, the logical arguments, it will use deductive reasoning to show that a statement is true. So basically, we will be given with a statement and we have to prove that either it is true or false by using logical arguments and deductive reasoning. Okay. Now there are different ways to write a proof. One of them is two-column proof. What is that? In two-column proof, we will make two columns. Okay. First, in the first column, we will write some arguments, and then we will give reasons. Okay, to every argument we will provide a reason. Then this type of by proving a statement by this method is known as two-column proof. Okay, now for example here, look at this example. We are given with a statement, write a two-column proof for the situation uh, for this one. Okay, and we are given that the measure angle 1 is equals to measure angle 3. This is given. Measure angle 1 is equals to measure angle 3, and what we have to prove, measure angle DAB, measure DBA, okay, DBA. This is this angle is equals to measure EBC. Okay, so what we have to prove? We have to prove the angle that I made with the red color and the angle that I am going to make with this color, they are equal. Okay, and what type of reasons that we can use? We can use logical reasons and we have to prove that statement. Okay, so let's see how we can prove that. So first we have some statements, and this is basically a solved example. Our purpose is not to solve them, basically our purpose is to understand what is two-column proof. So our first claim is the measure angle 1 equals to measure angle 3. It is true, right?
Yeah.
Because it is given to us that measure angle 1 equals to measure angle 3, that the angle of incident is equals to the angle of reflection, if I remember that was the example. So we can have that it is given. So I can write this statement because it was given to me. Okay. Then what it says, measure angle DAB, sorry, DBA. Which one is that? Measure angle DBA. The red one is the sum of two angles. This one, measure angle DBE. Okay, DBA is the sum of measure angle DBE plus measure angle EBA. Are you getting this point? Measure angle DBA is the sum of measure angle 2 plus measure angle 3. Okay, this is basically which property? The angle addition postulate. What it was, for example, if you are given with the angle, if you are given with two angles, then you can and this angle would be the sum of these two angles. Okay,
Mhm.
this total angle is sum of this one and this one. So by using that postulate, we can write this. Then measure angle DBA is equals to measure angle 1 plus measure angle 2. How can we write that? We already know that measure angle 1 is equals to measure angle 3. By using this given statement and by using the substitution property of equality, I substituted 1 instead of 3. Clear?
Mhm.
Now, measure angle 1 equals to measure angle 2. What it is? This is measure angle EBC. This is measure angle E, the one which I am going to make this color. Measure angle EBC. From this to this first, and then this one. Okay, so it is 1 plus 2. So this is now what we did. We established that we proved the result. What we did basically, we considered that thing. Okay, we proved that it is equals to this. Okay, then for that one we got this example. So from if you look from for point 3 and 4, we have measure angle DBA equals to this and this equals to measure angle EBC. So by using the transitive property of equality, we can have measure angle DBA equals to measure angle EBC. Is it clear? This is a very
Yes.
this is a very short uh, theorem basically. Okay, that we just proved. What does the mean of a theorem? A theorem is a statement that we have to prove. Okay, a statement that we can prove is called theorem. Look at this. 6 step 2 column proof are shown. Copy and prove. This is what you are given, and this is what you have to prove. Okay, what it tells us. T is the midpoint of the line segment SU. Okay, T is the midpoint of the line segment SU, and you have to prove x is equals to 5. So first statement is that T is the midpoint of SU. It is given to us, right? So what is the reason? Because it is given to us. Then they said the length ST is congruent to TU. Why? Because T is the midpoint. If you know there is a midpoint of the line, then it would be equidistant from its endpoint, right? The midpoint is equidistant from both ends. So by using that property or by using the definition of the midpoint, we can write that argument. Is it clear that ST is congruent to TU? How can we say that? Is it clear?
Yeah.
Okay. Then we wrote that ST equals to TU. We are okay. If we are not writing that these are the line segments, that means we are writing their measure values. And I think in the beginning I explained you that we are writing the if we are writing the measure values, that means you can write equality sign, and if we are not writing the measure values, that means we will use the congruent sign. Okay, there are two ways. Either you can write M, means if I'm writing measure of st, that means its length, or if I'm just writing st, it also means the length of the line segment st. Okay, so we turn this into equality. Now we did in the next step. In the next step, we substituted the value of st by 7x because it was given to us, and tu by 3x plus 20. Clear? So what we did, we just did Substitution, we use the substitution property of equality. Got it? And then we have to solve this equation now. How to solve it? I think it is very clear, very easy. 7x equals to 3x plus 20. In the first step, we have to subtract 20 from both sides. Let's subtract 3x from both sides. By subtracting 3x, we will get 4x equals to 20. Okay? And then, this is the first step. I got this by using the subtraction property of equality, that 4x equals to 20. Is it clear?
Yeah.
Okay, then I have to divide both sides by 4 to get the value of x, so I will get x equals to 5. What I did, I used the division property of equality. Is it clear
Yeah.
that how by using the properties I am moving forward and I can do the next step? So finally we prove that the value of x is 5. Okay, let's move to the next problem. It is again an example. What it says that write two column proof for the symmetric property of the segment congruency. What is the symmetric property of the segment? That if the segment LM of for congruency is congruent to the segment NP, this implies NP is congruent to LM. Okay, so we are given with this and we have to prove this. Clear? So let's see how can we prove that. This is exactly what I told you. Now let's begin to the proof. We wrote the first statement that LM is congruent to NP because it is given to us. Clear? Then if they are congruent, that means their measures are equal. So by using the definition of the congruent segment, I can write LM equals to the line segment LM. It is basically its length. It is equals to NP by using the definition of congruent segment. Okay. Now this is a number. This is also a number. And in numbers, we prove that we already know that there exists the symmetric property. It doesn't exist in congruency. It was existing in numbers. First, what I did, I converted the problem from congruency to the numbers, and now I will use the the symmetric property of numbers. Then I can get that because the symmetric property exists for equality. Clear? Is it clear how we are getting the things? Can you hear me? What, are you getting the things or the things
Yeah.
are harder? Okay, so if you are getting them, please, you have to response. No? Okay, then from this equality, I can write the congruency relation. So we wrote that NP is congruent to LM by using the definition of the congruent segments. Okay. So finally, we assume that LM is congruent to NP, and then we prove that NP is congruent to LM. Okay. Okay, though. Just read this and try to prove this. Let's see. You have to do this example. I want to see how much you know.
I have to do this part, right?
Yeah, you have to do this part. You have to explain all the things to me. You can take my help. Okay, you have 3 to 4 minutes to prepare. Then you have to explain each step.
Okay.
Okay, please start.
Okay. So for the first one,
First, explain the statement.
so the property of the midpoints, if you know that M is the midpoint of a of a line AB, prove that AB is
Beta,
equal
this
to
is not
AB.
line. This is not line. This is line segment. Okay. There exists no midpoint for the line. I think we spent 1 hour on explaining the difference between what is line segment, and what is ray. For ray and for line, there is no midpoint. The concept of midpoint is only for the line segment, okay? Because
Mhm.
line segment has endpoints, okay, and a line has no endpoint. Due to that, a line has no midpoint also, okay. So, okay, please let's explain it further.
So we have to prove that M is the midpoint of AB, then A is equal to 2 AM, AM is equal to 1/2 AB.
What does it mean? let me explain this to you. The question is, prove this property of midpoints. If you know that M is the midpoint, this is given to us of the line segment AB. Prove that AB is 2 times of AM and AM is 1/2 of AB. Okay, so this is what we have to prove. Okay, we are though this is very common thing in terms of the midpoint, but we have to prove that. Okay, so initially we are given that M is the midpoint. If M is the midpoint, that means the segment AM and MB, they are congruent. Okay, by using the definition of midpoint, it needs to be in the hub. So these two segments, they must be congruent. Okay, then by using that, we have the definition, we applied the definition of the midpoint. Okay, and we got AM is congruent to MB. Is it clear? Okay, then because they are congruent and I have to move towards the equality, I use the definition of congruency to equality. I turn them into equality by using the definition of congruent segments. Okay? If two segments are congruent, then their lengths are equal. Okay? So I just change the sign of congruency and I move to equality. Is it clear? Okay, now look at the total distance from A to B. The total distance from A to B is sum of two distance A to M and M to B, right? So this is this definition or this property of the segment I applied here and I wrote AB as a sum of AM plus MB. Got it? Is it clear how I got this point? By using the concept of the segment, then I have to substitute now. I got that AM is equals to MB, then I substituted the value of AM here. Instead of MB, what I wrote? AM. So I use the substitution property of equality. Clear? What is the substitution property of equality? If A equals to B, then I can substitute B in any expression, right? I think we did that example x, we assume x is equals to 4 and we used it in x minus 1. We use that in x minus 1 expression. So we can use that. This is a substitution property of equality. Now am plus m, the result is 2m by the help of distributive property. Okay, we can add them. X plus x is 2x. How? Because it is just 1 plus 1x, which is equals to 1x plus 1x, which is x plus x. So from this step to this step, if I reach, this is basically 2x. Okay, so we use the distributive property here. Then by dividing both sides with 2 or by using the division property of the equality, I got AM is half of AB. Is it clear?
Yes.
Okay. Now look at next question. What it says. It says that you are given with this line segment PS and we are given that PQ is equals to RS. PQ means this length is equals to this length. Got it? Then we have to prove PR is equals to QS. P to R, what does it mean? This length Okay, and Q to S means this part, that they both are equal. That's what we have to prove. Okay, so if you just see what is happening, we are given with the length of PQ and they both are equal, we have to add a same number on both sides. Okay, so that's what we are going to use here. We have PQ is equals to RS, it was given to us. Okay, then now I am adding QR on both sides of the equation. This is the which property? Addition property of equality. Okay, with the addition property of equality, I can add QR on the both sides because it is the same number. Okay, then look here now. What is PQ to QR? What is PQ to QR? Hmm? Can you tell me? PQ plus QR is PR.
Mhm.
PQ plus QR, that is equals to PR. Okay, and similarly QR to RS, this is QS. Okay,
Mhm.
now their left sides are equal. That means their right sides are equal. This is basically, which property is this? This is uh, transitive property. Clear? This is the transitive property of equality. By using the transitive property of equality, we can say that. Clear? Is there any question? Then, if you haven't any question, then we will move to our last question for today.
Mhm.
What it says? It says that you're given that angle A is a complement of angle 1 is a complement of angle 2. What does it mean? Can you tell me what does complement of an angle? Kilometer?
Yeah.
What is complement of an
The given angle one is complement of angle two. Angle two is so.
angle? No, no. They use the word no, complement. What does that? What does it mean? Complement of an angle means when you add it to the original angle, the sum would be 90. Okay,
Mhm.
their sum would be 90 degree. If two angles, measure angle 1 plus measure angle 2 is equals to 90, then measure angle 1 and measure angle 2, they are complement of each other. Okay, so we
Uh-huh.
are given that they are complement. Then we have to prove angle 2 is congruent to angle 3. Okay, this is also given. Then we have to prove angle 1 is a complement of angle 3. So we are given that 1 is a complement of 2, 2 is congruent to 3, 1 would be the complement of 3. So how we will prove that? First, 1 is a complement of angle 2, it is given to us. Then again, 2 is congruent to angle 2 is congruent to angle 3, it is also given to us. Okay, then what we did, we said that measure angle 1 plus measure angle 2, their sum is 90 degree. How we can say that? By using the definition of complementary angle. Okay, so you want me to, with what information I can write this statement? Just by using the definition of the complementary angles. Okay, then we establish that measure angle 2 is equals to measure angle 3. Why? Because measure angle 2 was congruent to measure angle 3, then angle 2 was congruent to angle 3, so measure angle 2 will become equals to measure angle 3. This is the basic definition of the congruence angle. As we were doing firstly, dealing with the congruent segments. Now, I can write, what is my target? My target is to prove 1 is a complement of 3, right? So in this statement, I can replace this measure angle 2 with measure angle 3, because measure angle 2 is also equals to measure angle 3. So I can substitute the value this measure angle 3 here. So the statement will become measure angle 1 plus measure angle 3. The result is 90 degree. Okay. Then by this statement I can say that the angle 1 is the complement of angle 3 by using the definition of complement. Okay, by using the definition of the complement. Is there any question?
No.
Okay, thank you.